Good afternoon, everyone. My name is Joel, and today I'll be presenting on the topic titled Unveiling Competition Characteristics from Annual Reports. This is a joint work done with my advisor, Associate Prof. Wang Kewei, and we are both from the National University of Singapore. Now, as the title suggests, this work is about proposing the use of ChatGPT to extract relevant aspects of firm competition for annual reports so that we can learn meaningful things about a given firm's competitive landscape. Now, before I delve deeper in our proposed artifact, let me begin by starting with the necessary background behind the motivation of this paper. First, understanding the competitive landscape faced by a firm is important for various stakeholders, such as its researchers, investors, and decision makers to make informed choices. Traditional methods used to measure competition, such as the Herfindahl-Hoffman Index, have been widely used in various social science research and for good reason. These measures are easy to compute and understand. However, as an aspect of competition looking only at the market share concentration of an industry, these are often not sufficient to capture the full complexity of competition faced by a firm. And we can see why, because what human analysts does typically when they want to formulate a viewpoint of the nature of competition faced by a firm, right, is to compile secondary research from a variety of different sources, be it from news, annual reports, or other reports written by other analysts. But this can be pretty tedious, so in the recent decade, there have been many works from both academic researchers and practitioners alike to try to use text mining methods to extract useful information from text sources. And if we actually survey on the academic work on text-based measures of competition, right, they range from work looking at how many times a firm actually discusses about competition in the 10K. 10K is regulatory annual report filing that he has to file for the US firms. And they also look at whether rivals actually mention it a lot of times in the 10K as well. So these works are all very interesting, and they are very meaningful in advancing the state of the art. However, there is a gap in the literature in that most of these work only typically look at one aspect of a time, right? It does not really mimic the way how a human analyst will actually do or approach this problem, which is basically usually involve a multiple faceted lens. In other words, they look at multiple factors at a time, right? These works also heavily rely on older NLP techniques, such as word count frequency, which may not actually capture contextual or complex information. Now, where the opportunity is to kind of use ChatGPT in order to address these limitations, because ChatGPT will be able to do targeted aspect extraction to unveil more information about the nature of competition the firm is facing. So with that, I'm now formalize the research objective and the approach to doing it. First, our research objective will be to develop a LLM-based artifact that can allow for the extraction of relevant aspects of competition, actually show that these features extracted can be used for downstream tasks. The general idea is we're going to take documents of interest relating to your firm. I'm going to use LLMs to answer certain competition relevant queries, and then test these extracted features in both in a regression and predictive setting. And I will now talk about how to actually construct these competition relevant queries, since this will be a very, very important question to answer. The idea here is to use a well-established framework for competition analysis. There are many available, but the one that we will use will be Porter's 5 forces, since this is most highly cited in management literature. Porter's 5 forces is basically a framework for analyzing the operating competitive environment. It's developed by a very famous researcher by the name of Michael Porter in 1979. It's basically looking at 5 dimensions relevant to competition, such as threat of new entrants, threat of substitutes, intensity of competitive rivalry, bargaining power of suppliers, and bargaining power of buyers. He actually wrote a very long seminal paper on these 5 factors, and within each of these factors, right, he actually wrote many different subpoints. We carefully read the subpoints and formulated the questions which we felt that the 10K will be able to answer, right? So we formulated 7 questions. Due to time constraints, I won't be able to cover them, but I just like to mention that we also added one more additional question on the optimism of a company in its strategic disclosure, because since we are going to use annual reports as our source of textual information, and the accounting literature notes that tone of report to be a very particular strategic element in disclosures, we therefore decided to reference the paper and also test for optimism, right? But for the most part, we formulated most of the questions based on Porter's work, except for one question, which is from an accounting accounting paper rather. So I'll now move on to our experimental study. So as mentioned, we are going to study and analyze the effect of the GPT-generated responses on a dependent variable of interest. So we will test it on a regression setting and out of sample radiative setting. So what should the dependent variable of interest be? So the dependent variable of interest we are going to use will be Tobin's Q. Is sort of a measure for firm value. And we note that the reason why we do this is because we note that the firm value is one of the most common dependent variable of choice for firm studies looking at competition. And it has been well established in the literature that competition is indeed related to firm value, right? And well, we can see why, because if a firm is unable to do well with competition, it could potentially erode firm value, or at least the market perception of firm value, right? Now that we settled the dependent variable of interest, what's left is to decide on the regression specification we should actually base our study on. So the regression study we are going the reference regression study we are going to take is from a previous ISR study that looked at determinants of firm value. They also used Tobin's Q. And what they did in this study is to investigate the effects of R&D and advertising on Tobin's Q. And they also controlled for other factors such as the size of the firm by assets. And this size indicator is actually referring to the locked sales revenue of a firm, and whether or not this loss indicator is referring to whether or not they made a loss in the preceding year in profits. So they also control other fringe effects. So we are going to take these as a base specification, and we are going to somehow add the GPT responses into these, the information in this GPT responses in this regression, and see if the theorized, the coefficients are actually consistent with the theorized mechanisms of the relationship between the answers to these questions and the dependent variable of interest, right? Like for example, we saw there's one question on whether they expect increased competition. We would expect increased competition to erode firm value, or other things equal, right? Ceteris paribus. Okay, now I'll talk, before I delve deeper into our artifact, I'll talk about more about the pre-processing of our work. So let me clarify that the main input for the model will be 10K regulatory filings, the annual regulatory filings rather. So these are reported by US firms yearly. So we're going to use this information together with necessary fundamental information from CompuStat and academic database. And what we're going to do is we're going to shortlist all the 10K reports of all NYSE and NASDAQ IT firms. For definition IT firms, we reference existing IS studies which actually use SIC codes in standard industry classification. This is basically an industry code mapping. So they have the mappings 7370 to 7379 for software companies and 3570 to 3579 for hardware-based companies. So basically, these will be used as a base, and we obtain 4,300 firm year 10Ks from 760 companies, right? And the reason why we don't see 7,600 firm year observations is because not all the firms actually exist in this period. Some establish halfway in and some also drop out, right? Now we talk about our proposed artifact. So our artifact consists of 3 stages. The first stage will be to identify the relevant text for input. So the 10K document is really long. So what we are going to do is to identify the text that's most relevant to input. part of the reason is to save computational costs, but one of the main reasons is because the LLMs typically have an input token limit. And at the point of time, when we work with ChatGPT, the token limit was much lower. It was at most 4,000, including in response. So I guess now, since ChatGPT has expanded it, there's less of a need for this stage, but we still put it in here because there will be other LLMs with a smaller token limits, and people will want to save computational costs. So this stage will still be needed, and especially the case where we see financial documents being hundreds of thousands of tokens, it's hard to imagine that it's probably more efficient to actually identify the parts using to shortlist the parts that are relevant, they can answer the questions, rather than have the LLM actually look at the whole document and answer questions based on the text, right? But this could actually change depending on the state of the art for LLMs, right? So one example of this extraction is to having this long 10K and basically identify the different parts of the 10K, and to identify the parts that we can ask questions on, because they can be in different parts of the document rather, right? So once we have the relevant text for asking questions on it, what we're going to do is to extract multiple aspects from the relevant text by actually prompting the series of questions we saw earlier in the previous slide. And we're going to employ a series of yes/no questions for this pilot study. We saw the questions earlier. Basically, what I want to mention is that this stage is highly customizable based on the needs of researchers, so we don't have to be limited by the questions that is focused on this pilot study. Anyone can ask any kind of questions that due to power large language models, right? It isn't fixed compared to many other NLP kind of work. So after we get the GPT responses, what we're going to do is that we are going to post-process it. First, I want to mention that when we actually query the answers to the questions, we also ask it to explain why by quoting from the text. And the reason why we want to do this is to force the LLM to consider the text when answering the question. We found that it actually reduced the chance of hallucination. In other words, they reduce the chance of actually making up answers. So we can understand why, because this is as a human analogy, when you ask someone to actually look at the text and answer based on the text, right, and to quote, they will be less likely to make up answers, and they will be more carefully looking at which part of the text could actually support their proposed answer, right? So after we get this GPT response, what we're going to do is we are going to do post-processing for use for regression and predictive models. So the reason why we have two different approaches to doing it is because our secondary objective for this study is to figure out in what way can we actually use the GPT response for unveiling more information about competition. So the first one is to just simply take the text transformation. We just transform it into simple variables with discrete levels. In this case, since we use yes/no questions, it can be mapped to 1 or 0, but it could, in other instances, you could actually map it to for example, high, medium, low. You could map it to 2, 1, and 0, for example, right? The second approach is to take the embedding. So as I mentioned, we got the GPT to explain the answers. So we can take these text responses directly by converting them into numerical representation through pre-trained language models. And the results for the regressive study are pretty consistent with theorized mechanism. For example, we can see that increased competition do in fact erode firm value, increased price competition also the same. And when a company has efforts to differentiate their competitors, as expected, we will expect it to have higher firm value as viewed by the market. Optimism also have higher firm value, and so on. So with the exception of, I guess, one, where company as discussing firm impact of new competitors, we will expect it to be negative. However, it's positive. But we also noted in various other accounting literature that firms that may not necessarily want to discuss the emergence of new competitors, because the emergence of new competitors may actually undermine investors' confidence. So it can be a strategic choice of part of the managers as far as new competitors is involved. So they try to tone down the language by saying they have increased competition, but not mention about emerging competition. And basically, the ones that I've mentioned about newer competitors tend to be the ones that are very well equipped to deal with the threats, and they acknowledge them very confidently. But high level, I think is that we demonstrate mostly consistent findings on our discussion, with the signs of coefficients aligning with the expected theoretical justification. And the results do in fact suggest that qualitative responses to questions about competition do in fact contain valuable information relevant to domain skill. And that researchers and practitioners could consider utilizing LLMs to extract useful information or to pilot tests for hypothesized variables of interest this way. Okay. Now, for the results for the predictive study, first let me mention how we do the predictive study. So we take the embeddings and together with other control variables and try to run it on a machine learning model. We're going to predict Tobin's Q 1 year in advance in an outsample setting, meaning that we are going to we're going to train based on 2010, 2018, fix the model a priori, and then we validate it based on 2019 and 2020. Okay, and it turns out that the binary response from the GPT questions, the binary transformation one, yes or no responses, do in fact improve on the base specification. They do add value. In fact, for all the models tested, it was actually less. RMSE, the metric of performance will be RMSE. But when we actually use the embeddings, right, with our second approach, they actually perform worse, right? Not only worse with respect to binary response, they actually worse with respect to base specification. So I think we try to understand why the embeddings perform worse. One reason is classic case of overfitting. We actually verified this because we noted that the training RMSE for all 5 different models, right? Actually, the training error was in fact lower. That means that it isn't a problem with explaining the results on like the in-sample period. The problem is the generalizability, right? One possible reason is because of dimensionality. Embeddings are typically high cardinality in nature, and we only have 4,300 samples. So 4,300 samples is a good amount of samples with respect to a lot of firm studies, but maybe to utilize embeddings you need a lot more. It's also possible that full detailed explanations just do not generalize as well as simple explanation. That could be one possible reason. And so what could findings tell us? That GPT responses to queries can indeed add value to competition analysis when used in the correct format. In this case, the binary response variables seem to be a suitable medium. The findings aren't necessarily indicative that simple ways do always beat using a whole text, but I think it should be something of researchers and practitioners to keep in mind. But to validate more rigorously, we will need to test on more richer data sets and test on settings where the relationship is less time variant. And then the conclusion is that we presented an artifact leveraging ChatGPT to analyze competition by extracting aspects from long unstructured text such as 10K filings. This approach addressed the limitations of existing measures, thus offering a more holistic understanding of competitive landscape through a highly customizable and interpretive Q&A approach. And in terms of findings, we demonstrate in a regression pilot study how a ChatGPT approach can contribute to the understanding of competition characteristics by allowing one to be able to verify or validate potential statistical significance to a target dependent variable. And secondly, our predictive study also sheds light on how we potentially create useful feature engineered variables in ChatGPT responses, most notably that sometimes doing it in simple transformation approach may actually beat using the whole text using complex text embeddings. But as a work in progress, we acknowledge there are several limitations we could do better. Namely, we could use more data sources in order to answer a greater variety of questions or aspects relevant competition. And we could also test on a wider variety of firms beyond just IT firms. And finally, we should also validate the ChatGPT response against human response to see what areas could answer differently. So with that, I come to the end of my presentation. I realize that I'm running short of time. So any questions, I'll be happy to take them. If there's no time, feel free to reach out to me at this email. Thank you.